Hola amigos, so now let's complete the definition of stability and control with this last topic, that is partial derivative. And here you are seeing the two ways in which we can find the derivative of a variable with respect to an independent variable. Okay, so here let's say the first one, let us consider the first one, which is the total derivative, or say it is also known as the substantial derivative. And f of x is simply here is a single variable function of x, and that means it only depends upon one independent variable, that is x, which is responsible for the variation of f of x. So any change in x will bring a change in f of x, and it is defined mathematically as df by dx, which is equivalent to limit of delta x tends to 0 for function f of x plus delta x minus f of x by delta x. It is generally, you might have learned in your elementary classes that it is generally represented as the slope of a curve, so you can remember in that way as well. So just to give you a flavor of how you can understand it better, I would say, let's say f of x is your gate exam performance in your gate exam. So f of x being your performance in your gate exam, let's say it depends only on one variable, that is your efforts. So let's say the more the effort you put, the more will be your performance, or more efficient will be your performance in gate exam. So f of x is directly proportional to your your performance is directly proportional to your efforts. So the analysis of performance with respect to efforts is given by df by dx as shown here. So let's say that your performance is now dependent on many other variables. It's not just efforts. Earlier it was efforts because you know that you are determined to do gate exam and you have all the material beforehand, you are guided and you have confidence in yourself. So you can only crack gate exam by performing good and creating and by putting your effort sincerely. So let's say now your performance is denoted by g of xyz function, which means your performance is now dependent on different parameters x, y, or z. X, same your efforts. Y, the time that is how much time you are left for the gate exam. And z, the environment you are living in. Okay, so it could be a happy environment or it could be a rough and tough environment. That depends how effective you are going to perform in your gate exam. And which is why you can say, if you want to analyze your performance for gate exam with respect to each of these variables, then you have to analyze them separately and individually with respect to a single variable, while keeping the other variables as constant. Let's say earlier we talked about the total and substantial derivative, and now here we are talking about the partial derivative. Okay, so the partial derivative here is analyzing your performance. Here del g by del x, g is your performance over here and x is your efforts. So it is equivalent to the limit delta x tends to 0 brackets g of x plus delta x, keeping your time and environment where you are preparing for gate exam as constant. Only your efforts are changing. Someday you are lazy, someday you are pumping and you are very confident, and these all are your contributing to your efforts for gate exam. That is reflected by delta x minus g of x, y, z, where y and z will be the same, only the change in your efforts will be analyzed, that is delta x. How much happier you are earlier, or how much happier you are now with your performance. Okay, delta x is that change. So delta x is actually how much efforts you are putting, so that will be determining your performance. Keep that in mind. So, and if you want to analyze your performance with respect to the amount of time left for the gate exam, that is y, then you have to keep your efforts every day. The same amount of effort should be put, that is x should always be the same, and z, that is the environment where you are living, should be the same. Let's say for the timing, make it physical environment. Let's say the temperature in which you are staying is 30 degree, so you want to keep the temperature as 30 degree for till the gate exam happens. And so we have over here your efforts are always the same and the temperature is also the same, only the time, that is amount of time left, is decreasing day by day, which is represented here by delta y. And the amount of time left is changing by delta y, and your performance g will be analyzed with respect to the time as shown here. Del g by del y is equivalent to limit of delta y tends to 0 brackets g of x comma y plus delta y comma z bracket closed minus g of x, y, and z divided by delta y. So similarly you can analyze your performance del g by del z, keeping x and y as constant, which means your performance will depend only on the environment in which you are staying. Okay, so another aspect of total and partial derivative can be learned from aerodynamics book of J.D. Anderson, and we have over here. So here you can see that dt by dt, dt over here is capital T over here is the temperature and small t is the time. So you are seeing actually the temperature variation with respect to time. And here you are actually seeing on the extreme left hand side, you are seeing the total or substantial derivative. Okay, so and it is the sum of the local derivative and convective derivative. So the local derivative, as you can see, is partial derivative del t by del t plus v dot del times capital T. And here you can read what it actually means. Okay, so let me just give you a hint over here, and you may pause the video and read all this, the second para. And just to let you know what is this, uh, the substantial derivative is the sum of local derivative and convective derivative. So what is local derivative? Local derivative is simply over here, as you can see, is the partial derivative of temperature with respect to time. So let's say you are sitting outside and you stay there for the whole day, and you analyze the temperature from sunrise to sunset, and that variation at a fixed point where you are sitting is this partial derivative, that is del t by del t. Okay, so let's say now you are moving from where you were sitting outside your home and now moving inside your home. So now you are moving, so you will also analyze or feel the change in temperature when you move from outside to inside your home, and that change is known as the convective derivative. So earlier we analyzed at a point the temperature variation with respect to time, and the convective derivative represents the variation in temperature with respect to distance, okay, from one point to another. And from here you can learn about it quite more clearly. So you may pause the video and learn from it.